Power electronics is evolving fast, and the industry is buzzing with innovation. At APEC 2025, we asked experts a simple question: what's the most exciting thing happening in power right now? From AI-driven systems to wide bandgap semiconductors, biofuel cells, and breakthroughs in isolation and measurement, here's what they had to say.
So I personally am very excited about biofuel cells and biofuel in general, and using maybe something like that's renewable or based from the body, using that type of energy and converting it into electricity. I think that's a super exciting field that I love seeing customers create new innovations for.
Specifically for Apex, my opinion is it has to do with materials. Okay, so historically, all of our circuits have been built on silicon, right? But now with the introduction of silicon carbide and gallium nitride, we're reaching new levels in power, frequency, and voltage capability. So I think that's going to not only increase the amount of applications we can support, but it's going to really reduce the size of the packages that we're introducing to the entire market. Excuse me. So not only does it increase our market share, but it allows us to offer new and innovative products to multiple markets.
It's wide bandgap technology like silicon carbide. This has created new applications that didn't exist before. Good example is eVTOLs. They never existed before silicon carbide. Now with silicon carbide, those power systems can be smaller, more efficient. This really is an enabler for those type of applications.
There's many things that can be taken into account. The thing is that the introduction of silicon carbide that dramatically changed the way to address high power and high voltage. We can make much more with silicon carbide due to the very low switching losses. Also the availability of simulation tools that facilitate the design and make the access to, let's say, the real waveform and the real virtual prototyping much easier than before and much faster.
So I'd say it's the device. Now we have the 1700 volt GaN. So rather than just pushing the voltage level, we're also pushing the topology. So now we're using the 1700 volt GaN in a multi-output design where we can have ZVS on the primary switch, which is 1700 volt GaN, pushing the efficiency to our next level. So yeah, I'd say both the device level and also the topology level. So we keep pushing both.
I would say that we're on the cutting edge of a major technology change in power supply design based on the silicon and semiconductor industry. I mean, more companies are using GaN, silicon carbide, and the more we use, the more the prices come down, and it makes it far more accessible to everybody. And with that, so you increase the switching frequencies, that then you can reduce the size of the transformer, you get better reliability, you get far more efficiency increases, and I'm kind of excited to see what's going to happen over the next 5 years.
So as we know that the AI is driving the industry to the different era. So with the GPU, ASIC, FPGA, the system board gets very condensed, very small size, very density. So bringing the power, that would be a biggest challenge. So power electronics today, working on the system integrations, bringing all of the passive and active components together in order to really create a form factor to enable this AI or any other chipsets challenges. So from my point of view, the power electronic is driving towards the power density and make power density as a challenge to solve all of the upcoming problems for the AI and other applications.
So one of the biggest challenges that we've seen from our customers is when designing with high power, there's often issues with ground loops, especially at higher voltages. If we're testing double pulse, for example, when you're measuring on the high side, there's some limitations to what you can do if you don't have the right isolation. And so we've innovated now with our third generation of IsoView technology to bring better solutions and different solutions to our customers. So for example, for voltage measurements, if you're in the presence of 1 kV, some of these measurements with traditional probes are going to be difficult. You're not able to reject that common mode signal. And so we just introduced a isolated current probe as well. many customers weren't able to measure current on the high side, but also on the low side, when you break that current loop, it reduces a lot of that ground loop and sometimes ground bounce and noise that we've seen really positive results when we hook up to the circuit. A lot cleaner signal and just better accuracy, just breaking that ground loop.
There are a lot of interesting innovations that are impacting power electronics, and I think one of the biggest hot topics that we're seeing today is AI data centers, right? What excites me is the whole chain from the AC grid all the way down to the gates of your processor. You want to make that as efficient as possible. And what excites me is a lot of the technologies that we're developing at TI that kind of hit all those different aspects. So we have new GaN devices, wide bandgap semiconductors that are making our power supply units more efficient. We have eFuse devices that are much more integrated, smaller, and easier to use. So a lot of these different things are coming together to really address a booming challenge that's facing the market today with power. How do you power AI data centers?
I think we're actually in phase 2 of the most exciting thing to happen in power electronics. I believe phase 1 was wide bandgap semiconductors, 5, 6, or 7 years ago. With generation 4, for example, we're starting to see that phase 2 where now designers can really push the limits of what wide bandgap can do. They're going from wide bandgap to wide bandgap, but they're going and they're going to start leveraging a lot more of the features that it has and really build better systems out of it.